I'm going to go through the process here of removing scale factor or setting the scale factor to 1 for coordinates in OS National Grid. The function I'm going to use first is called local site settings. This is one of two methods that I'm going to show. That function is found on the survey ribbon and is located over here towards the centre. And it works on the premise of selecting a central reference location, computing a ground scaling factor and applying that to the data. Before looking at that, I just want to mention that it's possible to turn on scale factor information so that it's visible within the points spreadsheet. So within project settings, under view and point spreadsheet, we scroll down to where the scale factor information is for the coordinate system. You can show the grid scale factor, the elevation scaling factor and the combined scale factor, which ultimately is what's scaling the ground distances to grid. If I then open a point spreadsheet, just close the properties dialog here, give a bit more wriggle room. You can see the grid scale factor column, the elevation scale factor and the combined scale factor here, apart from coordinate 7 for which there's no elevation. Looking at typical OS National Grid scaling factors here of about 0.9996. Okay, so that's just the point spreadsheet where you can visualize what's happening with the scale factors for the points in the project. One other function that I would like to mention is the inverse function, and this can be used to calculate or display what the ground and the grid distances are between points in the project, and this could be useful later for computing a ground scaling factor that's oriented towards the data set that's being processed. Now in this case I'm not going to use L7, I'm going to ignore it because there's no elevation for it. I'll just look at points from L1 through to L10 minus L7. So with this inverse function open, it's possible to query the distance between 2 points in the project and their relevant location with respect to each other. So having done that, we're reporting on points L1 and L6. You can see the grid distance here and the ground distance here. So as per usual in most parts of the United Kingdom with these scaling factors, the ground distance is a larger value than the grid distance, and that's the effect of the OS scale factor for the OS coordinate system and its associated projection. What I've done is I've created a very simple Excel spreadsheet, and I've just made a note of these values between L1 and L6, the ground distance and the grid distance here. What I've also done is taken a point that's roughly in the middle of the data set, and I've picked L3 and taken the combined scale factor, pasted that into my spreadsheet here, and this is just the reciprocal of this combined scale factor value. So it's 1 divided by this value here to give this number here, which in effect becomes our ground scaling factor. So if we multiply distances in the data by this value, then in theory should come to a value which brings the scale factor closer to 1. In other words, grid distances become very similar to the ground distances. So having done all of that, let's just look back at my plan view here. I'll close the inverse function and we're back at local site settings. So I'm going to click into the easting field and I'm going to pick L3 both in easting, northing and elevation as the reference position for the centre of the dataset. Click Use Ground Coordinates and then tick to compute a ground scaling factor, and we can see the number that's been calculated here. And I'll just transpose that onto my spreadsheet. So having transposed this number across, you can see it's the same at this number of decimal places to the value that was calculated from the combined scale factor. So those agree. The next thing to do with the local site settings function is to press OK, and that ground scaling factor will be applied to the distances in the project data using L3 as an origin reference. Okay, that has now been applied, and at this stage we can look at the point spreadsheet and see how that has affected the combined scale factor, which again you can see here that the numbers have gone from the typical sort of OS 0.99964 type values to numbers which are very close to 1, ground scaling factor of 1, or a scale factor of 1 I should say. And if we use a compute inverse from point L1 to L6, we can see that these values have been updated. So the grid distance is closer to the ground distance, but it's not perfect. There's more scaling required here to get it perfect based on this orientation of the data. So I'm going to add these values to my spreadsheet. Those numbers from the inverse function, after applying the local site settings based ground scaling factor, have been entered here into my spreadsheet. Keep a record of what's going on. What I've also done is computed my own ground scaling factor, and I've done that by dividing the grid distance here by the ground distance to give this value. So this value is a localized value based on the inverse distances between points L1 and L6, and the reciprocal of that number is this one here. So let's see what happens if we put this number in that's based on the actual distances between the points in question at either end of this area, rather than basing a ground scaling factor on the point that's roughly in the centre. So I'm going to copy that and I'm going to paste it over here. So let's just double check that that is there. So yeah, 314, 314. So this will be our new ground scaling factor. Hit OK. And back to inverse from L1 to L6. Okay, so having amended the scaling factor to apply to the data based on the coordinates of the end values, we've now got a better scaling that's closer to a scale factor of 1. So the ground distance will not have changed, it will be constant, but here we can see that the grid distance is now 272.247, so much closer to a scale factor of 1. And again, if we look on the point spreadsheet, we can see what the combined scale factor is over here. So that's one method for taking a dataset in OS National Grid coordinates with OS National Grid regular scale factor and applying ground distance scaling using local site settings to achieve a scale factor that's closer to 1 based on the relationship between ground distance and grid distance for this particular dataset.